All right, I'd like to start off by introducing myself. Hello, my name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, a college professor or industrial trainer teaching programming skills required in manufacturing, a company looking for ways to demonstrate their software-based solutions, or just someone looking for ways to make IoT-related concepts easier to understand to employees or customers, I believe this presentation will offer some important options for you to consider. Let's start off by considering the skills gap. Now, if you've attended any of our fischertechnik education webinars, you've probably heard me discuss the importance of STEM education. Now, STEM, of course, is the acronym for science, technology, engineering, and mathematics, and it should go without saying that STEM education has been perhaps the most discussed topic in education for the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions we'll be looking at in this presentation, let's consider the last skill area that I just mentioned, that of a PLC programmer. First off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. Essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes typically found in an industrial setting, such as an automated manufacturing plant. As the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. To get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. In fact, a quick glance at the first page of recent job openings for PLC programmers on Nuvu for the date February 27th of 2020 showed 15 positions being advertised with salaries over $75,000, two of which, I should mention, listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time as this, workforce of tomorrow gets their training. More and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. So how long does it take? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, as you see listed on your screen now, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available. Of course, college and university programs, high school CTE or career and technical education programs, adult continuing ed programs, vocational training, technical training and trade schools, and employer-sponsored incumbent worker training programs. Now, this all being said, The question that still arises for the educator, whether they be in the university or vocational school classroom, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it more realistic and hands-on? But there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution, looking for ways to, to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Now, maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and of course there are more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, in both appearance and function, various automated or robotic machines and systems commonly used in commercial manufacturing. But before we look at these models, let me provide you with just a little bit of background on fischertechnik. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, in the fischertechnik system, it was created with more of an engineering mindset. And in this way, the core building block is designed to enable attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place, and the hundreds of different parts available will also help to address very specific design needs. Just to give you a little more background, the fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who was noted for countless innovations used in the construction and automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to anchor heavy objects to walls. His company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction. They also provide numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Now, many of the products offered by fischertechnik for the education sector are subject-specific sets, focusing on different STEM-related areas, things like mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system, and then perform various experiments which allow them to explore and understand aspects of that subject. There are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. In these project-based programs, students dive deep into engineering and learn all aspects of the design process. And this requires them to work in groups and create various devices and automated machines to meet the criteria put forth in a series of real-world scenarios based upon their own trial and error experimentation and research. That said, the line of fischertechnik simulation solutions, which are the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled, small-scale models which replicate in appearance and function various automated robotic machines and systems. Now, models in the fischertechnik simulation line include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even a high-base warehouse storage system. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations, a vacuum gripper robot, a high-base storage warehouse, a multi-processing station with an oven simulation, and a sorting line with color detection, all of which work together as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using fischertechnik solutions. Now, I'll apologize in advance as a few points are things I've mentioned before, but in each case, I do think it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, in both appearance and in function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because these models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Another factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each model, with one exception I will address later, is currently available in 2 different versions. First version is a 24-volt version, which is designed for use with industry standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or whatever others you may prefer, you can control these 24-volt versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language. Of the ones you see listed on the screen, if you like ladder diagram, you can use that. If you like sequential function charts, function block diagram, structured text, or instruction list, doesn't matter. If that's what you use with your PLC, that's what you can use to program the model. Now, I will note that with the 24-volt versions, no PLC is included with the models, and all programming and all programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. On the other hand, for non-industrial users and educators not versed in or familiar with PLC programming, there are also 9-volt versions of each model which are available. Now, these 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller. And each of these controllers, these 9-volt controllers, is pre-programmed using fischertechnik's own RoboPro programming software. Now, with these, the 9-volt versions, the only additional component required with the 9-volt versions will be the addition of 1 or more 120-volt power adapters as specified with each model. Otherwise, in most cases, these models should be ready to use right out of the box. Getting back to our list of advantages, if you are involved in demonstrating or exploring IoT, which of course is also known as the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. Here, the model is designed to be both controlled and monitored from a special web-based dashboard. We're, of course, going to discuss this in more detail later in this presentation. And getting back to the advantages, finally, fischertechnik simulation models are cost-effective. While I won't name names, I will say that if any of you have looked into any other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are only a fraction of that price, as well as being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's look at each of the models which are available. First up is the vacuum gripper robot. Now, as you're going to see in this video, the vacuum gripper robot is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. This model includes 3 encoder motors, 2 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component you'll see in the videos, and also a solenoid valve. The model's dimensions are approximately 9 inches by 19 inches by 15 inches, and it has a weight of about 7 pounds. The 24-volt versions of this model, as well as any of the other 24-volt versions we're going to look at, each have a relay board for motor polarity reversal and both a multi-pin connector with 26 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all of the 24-volt versions, will require you to provide both the PLC and the programming. The 9-volt version, which is the version you'll see being used in this video, will once again come wired to the fischertechnik robotic TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will mention that for this and all of the models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next, we have the automated high bay warehouse. Now, this model features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays and 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will note that this model is a favorite among educators I've talked to, I know, who teach programming, because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step, which will of course require its own specific coding. The dimensions for this model are approximately 19 by 28.5 by 15 inches with a total weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming, and the 9-volt version once again is pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required. The next model in the line is the multi-processing station with oven simulation. Now, the model we're going to see in this video features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter simulation with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 phototransistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches with a weight of about 11 pounds. Again, it's available in both 24-volt versions for use with the PLC of your choice, and the 9-volt version in this case is connected to 2 robotics TXT controllers. So in this case, 2 120-volt power adapters will be required for all operations. We'll just let this play out for another couple seconds. The next model in our progression is the sorting line with color detection. We're just going to kill that because we don't need their sound. Instead, I'm going to talk. The simulation model you're going to see here features a system for detecting work pieces of different colors and sorts them via conveyor belt with 3 different storage bins. Now, components used on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you need to provide the PLC and the programming. The 9-volt version again comes pre-wired to a pre-programmed TXT controller, and 1 120-volt power adapter is of course required. The next model is the factory simulation, which combines the 4 models we've just reviewed. The vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with the color detection into one self-contained material cycle. And we're just getting caught here. Just bear with us, we're having a slight technical. Glitch here, okay, let's see. All right. As we will see in a second, the cycle works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. After the workpiece has been processed by this machine, it's then sorted by the color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here. What I do want to discuss are the dimensions of this model as a whole. Now, as it again combines 4 individual models into one cycle, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a weight of between 43 and 46 pounds, depending on whether you get the 9-volt or the 24-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. A few other things to note. First, this is again available in both 24-volt and 9-volt versions. In this instance, the 9-volt version is wired to 5 robotics TXT controllers. But in this case, it will require 3 120-volt power adapters because of the way that some of the controllers are daisy-chained together. As always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware required. Again, each station on the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we've just discussed, who may need to transport their model or who just wish to protect it when not in use. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam. It is designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, with a weight of approximately 53 pounds. Please note that even when using the travel case, these models will still need to be shipped flat, despite the fact that it's standing on its side in the photo you're seeing here. Now, the next model is a basic conveyor belt. This is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions on the model are approximately 14 by 10 by 4 inches with a weight of under 2 pounds. Now, as before, this is available in both a 24-volt version, as you see on the screen now, and also 9-volt versions connected to the robotics TXT controller as shown here. 1 120-volt power adapter is required for all operations. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except this time with a machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches with a weight of about 3.5 pounds. Again, it's available in the 24-volt variation as shown in this picture, and the 9-volt version wired to the robotics TXT controller as shown here, which again requires 1 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. Now, this model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts I just mentioned, 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches with a weight of about 8 pounds. And it's available in both the 24-volt, the 24-volt version for use with PLC as shown here, and a 9-volt version wired to the pre-programmed robotics TXT controller, and again requiring one 120-volt power adapter. Next up is a variation on the idea of a pick-and-place robot, the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters. And axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of this model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. Now, as with the other models we've looked at, this is again available in both a 24-volt version for use with the PLC and programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models, all of which are available in both 24-volt versions and 9-volt versions. The next simulation model is designed to specifically address the topic of cloud-based monitoring and control. This is the Training Factory Industry 4.0. Now, this model was designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video provides a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The 6 fischertechnik TXT controllers control the learning factory. The controllers communicate with each other via standard MQTT protocol. The controller programs are written in C, C++, and the controllers arrive with the programs already loaded on them so that they can be used right away. The programs can be changed and customized. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The high bay warehouse is organized chaotically. There is no fixed space for a material to be stored. The system simply recognizes the next available space. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. Production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Pretty impressive, I hope you're going to agree. Now, just to go over it again, the following topics can be addressed with the fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, and digital traceability with NFC RFID technology. Customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, this model incorporates many features not found in the models we've previously discussed, besides just most notably the use of a cloud-based dashboard for monitoring and controlling the model. And it once again offers 3 different views: a customer view, a supplier view, and a production view. Some other examples of features not found on other models would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, will enable the positions of each piece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with each other. Now, as discussed, this model is currently only available in a 9-volt version, with the control facilitated through the use of 6 robotic TXT controllers. Now, unlike all of the other 9-volt versions we've looked at previously today, these are again not programmed not using RoboPro, but instead using C, C++. Again, all of the programming is preloaded so that once connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation PDF, you should be able to get started quickly. Now, dimensions for this model are approximately 39 by 31 by 16 inches with a weight of approximately 53 pounds. This 9-volt version will require the addition of 3 120-volt power adapters, the ability to access the internet, as well as a tablet or device for accessing the cloud-based dashboard. Now, as with the 2 factory simulation models we discussed previously, we recommend the travel case to help protect your model during transport or storage. Now, this of course begs the question, so what about the 24-volt version? Well, the answer is that that version is expected to be formally announced very shortly, literally any day now. The original thought was that we would have had this available for ordering by late spring, but with the disruptions caused by the COVID-19 crisis pushing everyone back somewhat, we hope to have that announcement, like I said, could be any day now, but we would expect by the end of the summer. And that's the Training Factory Industry 4.0 model. Of course, you might be wondering how much these models cost. So in that case, let's take a quick review of each option I've just discussed, along with the pricing for each of the versions. First up, the vacuum gripper robot. The 24-volt version with the part number is $8.99 each. The 9-volt version, which of course is more because it includes the controller, is $11.99 each. The automated high bay warehouse in the 24-volt version is $1,035. In the 9-volt version, pre-wired to the robotics TXT controller, it's $1,319. The multi-processing station with oven, the 24-volt version is just $989, and the 9-volt version is $1,479. The sorting line with color detection in the 24-volt version is $819 each, and in the 9-volt version is $1,129 each. And of course, I should point out again, these are all list prices. So when we get to the factory simulation, the 24-volt version is $3,729. Once again, this requires your PLC and all the programming. The 9-volt version, which includes all the robotics TXT controllers, is $5,239. The conveyor belt, the 24-volt version is $220 each. The 9-volt version with the TXT controller is $519 each. The punching machine with the conveyor belt, the 24-volt version is $289 each. The 9-volt version, once again with the controller, is $599. The 3D robot, 24-volt version, $829, requires PLC, of course, as all of them do. The 9-volt version with the TXT controller is $1,099 each. The indexed line with 2 machining stations, 24-volt version, just $879 each. The 9-volt version is $1,399 each. And the Training Factory Industry 4.0, the 24-volt version is to be determined. We should once again have that information hopefully very soon, knock on wood. Like I said, I would expect by the end of August, if not before. The 9-volt version, pre-wired to 6 robotics TXT controllers, is $6,495 each. Other items that I've mentioned, the 120-volt power adapters for the 9-volt models are $12.99 each. And the travel and storage case, which is used for all factory simulation and Training Factory Industry 4.0 models, is $1,000 each. So at this point, I'm going to open the floor up for any questions. If you do have any questions, there are 2 ways you can ask me. You could use the Zoom webinar chat window, which should be in the middle of your, or actually, no, excuse me, it's way at the end of your Zoom toolbar under the ellipses. There is a question and answer window as well, and that's right in the middle of the toolbar. So either of those options, if you do have any questions, you could ask. Going once, going twice, I don't see any questions coming up. So at this point, if you would like to take the next step, if you'd like to request a full color brochure and current pricing, if you would like to ask any questions directly, if you'd like to request a quote, or if you'd like to speak with your own dedicated educational representative, you can call us here in the US. Our number toll free is 888-561-7521. Once again, that's Studica US office. If you have a question that's a general question, you can email us at info@studica.com. Or if you have a specific question on any of the models you've seen today or any of the Fischer-Technic education solutions which are available, you can feel free to ask me directly. My email address, that's my direct email address, is lancezurek, LANCE.ZUREK@studica.com. On that note, I would like to thank you very much for taking the time to attend today's presentation. We do look forward to hearing from you soon. Thank you and take care.